Hello, my name is Igor and welcome to my tech fun, and in this video I'd like to introduce you 3D printing services by JLCPCB. And to clear immediately that this is not sponsored video, I got these test objects for free, but I'm not paid anything about this. Their primary services is PCB prototyping and manufacturing, but they also have 3D printing services, and the reason they accepted this video is that their prices are much cheaper compared to that one which I already showed in this channel. And in this video I will compare SLA versus MJF 3D printing methods. And I will use those standard test objects which I usually use on this channel. And this means that the results are comparable with those which I did in previous or I will do in future videos. Okay, about SLA. Stereolithography is the most common resin 3D printing process where some kind of light is used to cure liquid resin into solid material, layer by layer. And the material will be 9000 R photosensitive resin. On the website you have their specifications too. Now I noticed basically that heat reflection temperature is 46 degrees Celsius only according to their website, which sounds a little bit low, but don't worry, I will do the thermal temperature test too. The second is the MJF multi-jet fusion. This is an industrial 3D printing process which uses an inkjet array to selectively apply fusing and detailing agents across the bed of nylon powder, which are then fused by heating elements into a solid layer. And here the material will be PA12-HP Nylon. PA12, I know that this is less sensitive to moisture compared to the PH6. Heat deflection temperature is 100 degrees Celsius. And in one of my future videos, I will compare FDM using the ABS material, which are we already familiar with, well, at least I, versus SLM, which will be 316L stainless steel material. So I'm really excited about that, but I have to think over my test objects because probably I have to reduce them a little bit because I want to be able to break them with my equipment. Okay, let's see shortly the ordering process. After creating an account and a login, under the resources 3D printing I clicked on get instant quote, and here I uploaded my STL files, and then I had to choose the 3D technology and the material, and I also had to enter some description because it is required field. I clicked on save to cart, and then I uploaded the same files again, and this time I selected the MJF 3D technology. And again enter some description of the file, and again save to cart. And as you can see in the summary view of cart, the total is approximately $22 so far, very cheap. But I got the email that I have to re-upload some files because they cannot have these thin walls. These are designed for FDM printing for better adhesion. And this is the total. As you can see, together with the shipping and taxes, the total would be approximately $60. And now let's do the unboxing and take a closer look of these test specimens. Let's start with the resin. It looks like one is missing because I should have two of these, but I have to check because I had to re-upload this one without those brims. Maybe I forget to change the quantity to 2. Let's check quickly the important dimensions. Here the cross-section area should be 4 by 4 millimeters. Approximately 0.1 millimeter is the difference. Let's see this one which is printed in vertical position. Approximately 0.1 is the difference, which is acceptable. This object is for shear stress. The diameter should be 5 millimeters. And this is for torque test. The diameter should be 6 millimeters. 0.15 is the difference. Okay, this is for the bending test. The dimension should be 10 by 4 millimeters. Again, 0.2 millimeter is the difference. And this one, here 0.3 is the bigger a little bit. And this is for the creep test. This should be the cross-section 5 by 4 millimeters. This is 5.2 by 3.88. And now let's open the nylon. They look really nice. Look at this surface. I hope it's visible on camera too. Well, it looks like, yes, it was my mistake that it's suspicious because I have 3 of these. Okay, let's check the other dimensions. 6 millimeters, very close. This should be 5 millimeters for shear stress. Oh, very close. The bending test, 10 by 4 millimeters. A little bit bigger, maybe. There is some kind of brim. Let's check. 10.3 by 4.08. Okay. And creep test, this should be 4 by 5 millimeters. Oh, 400 by 526. Okay, in the meantime, I checked on computer. It was my mistake because I had to re-upload this for vertical printing. I can recognize this object, it is narrow in the middle. And I forget to change the quantity to 2. Because the original one had some kind of brim designed here for more stability for FDM printing, but here the narrow parts has to be removed. But with this nylon, I checked, I uploaded the correct file, but it looks like they used the wrong one to print the third object. And I can see from these lines that basically these are printed in same position. So unfortunately here I will don't have that test object which is printed in vertical position to see if we have some kind of weaker layer adhesion or something like that. So the dimension accuracy was approximately plus minus 0.1 millimeters with few exceptions. And now I will start with the mechanical testing, and I'm starting with test objects which are printed in horizontal position to check the tensile strength. Each object broke on that proper cross-section area, and here you can see the cross-section picture of these two materials. And for the layer adhesion test I have only one test object, and this was printed in vertical position. And it also broke on proper cross-section area, and for the feeling or the looks the cross-section is really solid. And it's time for the shear stress. This test object has a diameter of 5 millimeters. And as you can see, it has the shear from two sides, so it is double-sided shear stress. Wow, it just exploded. And now nylon. Nice. In both cases they are shared properly on those two cross-section areas, this means in 3 pieces, but the huge difference was until the resin just exploded, the nylon was shared slowly. I could actually feel that sharing process. And this is 3-point bending test. Distance between supports is 50 millimeters, and I'm starting with resin. I want to record the load at 2 millimeter deformation and the maximal load. And now moving to the nylon test object. And again a very different failure. The resin just exploded, broke into pieces. Until that the nylon just deformed completely until the end. Torque or twist test. This test object has a diameter of 6 millimeters, and this side goes into the vise and the other side goes into this digital torque meter. And I want to record the load at a 90-degree rotation and the maximal load. Now usually this test has similar results as a bending test, so probably the resin will snap very suddenly, so that's why I will wear my safety glasses, and the nylon will slowly deform. 1.5. 1.6 was the peak. Nylon. 1.5. 1.9. Oops. And as I predicted, the resin broke very suddenly. I got these very sharp edges here, and I could actually feel where the nylon will fail slowly. And now let's measure how brittle are these materials. I have these notch test objects, and this is ISO impact tester with half kilogram hammer, which is swing to the other side. That's the 0 position, and then we place here the tested object, and it will break it and swing to the lower position, and from difference in height I can calculate the potential and energy which is used for breaking these test objects. Resin, 0 position, nylon. So this is how they broke. For the first feeling I couldn't tell the difference, but let's analyze the pictures. On this scale, this is the 0 position, and this is after breaking the resin test object. And interesting, this is after breaking the nylon, which is weaker, this means. And if I measure everything from the 0 line, I can get these values, but I have to use this in calculation in meters. But I will show you all the numbers in result summary. Well, I still don't know how to use this information, but let's measure the hardness with this short D durometer. 73, 73, 73. Nylon 72, 72, 73. And it's time for temperature test, and I'm very curious if the resin will fail on so low temperature, because according to specifications the heat deflection temperature is 46 degrees Celsius, and from the nylon it is 100 degrees Celsius. And I will follow the temperature with this cooking thermometer, but this is just a backup measuring. Here I want to record the temperature when it starts with deformation, but this time it was not so obvious. I was analyzing the timeless footage frame by frame, and I noticed the first small deformation at 78 degrees Celsius. This nut is a little bit small load on it, and basically we'll see it was like a rubber. And only at 150 degrees Celsius approximately I noticed first deformation of the nylon, but it started here with the melting, but I couldn't notice the bending under the screw nut. 182 degrees Celsius, I will stop the measuring here. The nylon melted partly. Interesting, the resin is like a rubber, so with this small load I couldn't see the deformation. I have to analyze the timeless picture by picture, but with bigger load it starts with the creeping. I already know the results of the creep test. The nylon is already quite hard now, but as you can see it started with the melting here. The creep test, deformation of the material during the constant load. I have these test objects. The distance between these two reference surfaces is 12 millimeters. I will place this 1.25 kilogram load on them, and I will measure the deformation in next 5 days, and on last day I will place them in the oven and measure the additional deformation. Quite big deformation on both test objects. And I will measure now, and to more accurate measuring I am locking the position with this printed part. 19.32, 20.41. And don't worry, I will do the measurements off camera, only I will create a picture once a day. This is day 0, and this is after 24 hours, quite a lot of deformation on both objects, but later the nylon stopped with the creeping until the resin continued with deformation, and now everything goes into the heated oven. Oh, the resin will fail soon. I will remove the load because it will fall down. But the temperature inside was only 44 degrees Celsius. And after 1 hour on 45 degrees Celsius, let's measure the nylon. The resin got almost its original shape, well, not just almost. 29.69. And interesting, after approximately 20 minutes, they have very similar permanent deformation. These are all results in one table, which is downloadable from my website. This is the table for the creep test, and basically this is after the heating. I enter some numbers here so I can present it on a graph, but actually for the creeping I need difference between 2 days, and that's why I prepared this table. So 0 means no creeping, and this will be presented in a graph. Here I have only 2 test objects, here 3 for the tensile strength, here basically only 1 for the resin. But let's see the graph. So as you can see, with the creeping, the nylon is better, and it almost completely stopped with the creeping after maybe 3rd day. And it had some additional creeping, interesting, on 45 degrees Celsius. The resin continuously creeped even after 5th day. I noticed some deformation, and don't forget here it basically deformed completely on 45 degrees Celsius after maybe 15 minutes. Tensile test, well, the resin is a little bit stronger compared to the nylon, but this is interesting. So the layer adhesion test, here the resin printed in vertical position is almost strong like the horizontally printed version. So this is what I like with this kind of materials. The shear stress, well, the nanos was a little bit stronger here. With the bending test, I think the blue is the most important, the load at 2 mm deformation. So here the resin was stronger because it was approximately 6.5 kilograms until it reached 2 mm deformation. Interesting on torque test, usually I got very similar results like with the bending, but this time it was different. Basically the load at 90 degrees was very similar, almost equal with the 2 materials. And the impact test, so here the resin is more tough material, so the nylon is more brittle compared to this resin, but basically these are quite good values. Now the deformation, I couldn't really see, so obviously the deformation on the given temperature, so these are just approximate values. Interesting, you saw the resin was something like a rubber, but with that M10 nut on it didn't deform until maybe 78. I tried to analyze the time-lapse footage frame by frame, and the nylon, well, started with deformation, which I noticed at approximately 150 degrees Celsius. And I always measure the hardness, and maybe once I will know how to use this information. And now the conclusions. Well, very interesting materials, and I have to learn more about them so I can choose the proper one for my applications. And my favorite properties for the nylon was that horizontal or vertically printed one has almost equal strength, so we don't have that weaker layer adhesion effect. With the nylon, I know about its creeping properties, but actually stopped with the creeping on the 3rd day. But I was surprised that after I placed it in oven to 45 degrees Celsius for 1 hour, it has some additional creeping. Anyway, as I mentioned, very interesting materials. About JLCPCB services, so this is really cheap. I mean, if I would pay for everything, it would cost me $20 approximately, but additional $26 for shipping and some taxes for European Union. Now, I'm not sure is that $26 really realistic price. I mean, I usually order this kind of boxes from eBay, AliExpress, Banggood and similar, and they cost maybe $5 or something like that. So I hope they don't use that method, that integrate additional price into shipping. I'm very curious, so I will place another order from JLCPCB, and this time it will be their ABS FDM printing versus stainless steel powder, so it will be metal 3D printed part. And I'm very curious because I don't have any kind of experience with 3D printed metal. And it is always good to know the possibilities. So let's say you just want one, I don't know, metallic 3D bench or something like that, and it is good to know that where can you order from. I'm thinking to create a page on my website to collect 3D printing companies who offer these kind of services. And one important column would be the price. but I'm thinking maybe the price for the one bench or maybe 5 benches or something like that, but only price of the printing services without shipping or taxes, because that may vary from country to country. I'm just curious about your opinion about this. Okay, thank you for watching, and I hope you will follow me to that video too. Until that, happy designing and ordering.